Hey, hello,
There we go.
hello. Reviews. Hang on now. We gotta get a review right here. Gallery. There we are. There we are. Side by side.
There we are.
Great. Let me see where I am here. I'm right here. There. Okay.
There we go.
Oh, yeah. So I lost a monitor here just a short while ago, so I'm kind of a little bit off my game, but
There we
I'm
go.
off my game anyway, so it doesn't much matter, does it?
That's okay. It's almost summertime, so that's okay.
Almost. Absolutely. Okay, well, good evening, everybody, and welcome back to our Sunday night offering of astronomy edutainment, the Sunday Night Astronomy Show.
Hey.
My name is Chris Kerwin. I'm the creator of the social media channels known as Astronomy by the Bay. I am also an amateur astronomer and a member of the Royal Astronomical Society of Canada. Yay!
Hey.
Now, Mike won't be joining us this evening. He's enjoying himself this evening, doing something else, so we'll just leave it at that.
Yes.
We'll
Hey,
be back
Mike.
next.
He's going to be watching now. So, hey, Mike.
Yep. Good evening, Mike. And good evening to my brother, Danny, who watches our show faithfully every week. Good evening, Danny.
Hey, Dan.
Now, I would like to welcome back my other regular co-host from the Moon Shadow Observatory in beautiful Hampton, Mr. Paul Owen. Paul, good evening,
Oh,
sir.
good evening.
Hey. And we'd like to welcome all of you joining us from YouTube and Facebook tonight, and all of you who are joining us through the local Rogers TV network. Thank you very much for your support all along. So, on tonight's episode of the Sunday Night Astronomy Show, now over the past week or more, I guess a little bit more than that, we've heard some media hype about the coming planetary alignment that is occurring tomorrow. The suggestion is that 6 of the planets will be visible in tomorrow's morning sky. Now, although it is true that most of the planets will be aligned, it is not true that you will see all of them with naked eye. Now, still, planetary alignments are interesting, and they do, help us keep looking up. But what other facts do we know about the planets in our solar system, and how do we understand the terms when we're describing their positions, so that we can decide when it's time to go out and observe them? So, the planets and their characteristics we'll be talking a little bit about tonight in our discussion. So, and with Mike not joining us this evening, Vinyl Bud will be absent this week, but he promises to return next week. Paul is going to have another interesting Rosanna's fun facts for us to share, and I'll reveal a few of the things we'll be watching for this week, along with your wonderful photo submissions to share. So we'll get started then tonight with a discussion around our many celestial neighbors, and I'm going to give that part to Paul, who's going to lead us off in our talk.
Oh, okay. Is that how you plan it?
My planet. Where's my?
Oh, yeah.
Uh,
We were talking this week about what we were going to do with this week, and we thought the planets would be, first and foremost. Or certainly that's all the chatter right now about the lineup that's coming up with all these wonderful. That's tomorrow morning, isn't it?
Tomorrow morning. Yep.
Tomorrow morning, yeah. And what we would do, or what I'm going to do, my part of it tonight is I'm just going to talk a little bit about the planets, what they are, a little bit about their characteristics, and some interesting fun facts about them. And I'll go through that sort of thing. And then after that, Chris is going to talk to you, I guess, about all kinds of different things that they do, their characteristics in terms of their orbital habits. Orbital habits. That's a hard word to say, isn't it?
Hard word to say. Yeah. I'm glad you're
Orbital.
saying.
Orbitable.
Portable
Orbital.
habits. Portable habits.
Orbital habits. There we
We'll
go.
talk about opposition and conjunction and that kind of thing a little bit. So yeah,
It's
we're going to talk
exactly
mostly about the planet parade that they're expecting, and I'm going to talk mainly about why you're not going to get a chance to see it tomorrow. So
right. There you go. Perfect. So yeah, so that's what we're going to do tonight. So this is what we decided to do, and so let's get into it. So I'll start by sharing my screen and just kind of go over some of the things that I actually learned this week while putting this little piece together. So let me know when you can see that.
it's up.
It's up.
Mhm.
Wonderful. Okay. So basically, what we're going to talk about first is the planets and what they are, and essentially the solar system from the sun on out to Pluto. I am going to leave out the Kuiper and the asteroid belt. I don't know if Chris, if you were going to talk about those at all, but we can certainly chat about them as the night goes on. So let's look at Mercury. So the first picture you see is the planet Mercury. However, it looks like the moon, doesn't it? So let's talk
Does
a little bit
indeed.
about Mercury. Just hang on a sec here. I think it is. No, that's the image. No, that's it. Believe it or not.
Huh?
That
Oh,
isn't Mercury, but let's just pretend it is. How's that?
okay.
Yeah, I don't know why or where that came from. Hey, no, it is actually. All right. Okay. Anyway, let's get talk about Mercury here. So Mercury, let's talk a little bit about what Mercury is and what it's made of. So Mercury is the innermost planet of the solar system, and it orbits the sun at an average distance of about 58 million kilometers. And Mercury is also the smallest planet in the solar system, with a diameter of just right around 3,000 miles or 4,800 kilometers. Now, despite its small size, however, Mercury is actually the second densest planet in the solar system after Earth, and that is due to the composition of its core. Mercury possesses a core of iron, a fairly dense material. Interestingly, though, relative to Mercury's size, it has the largest iron core of all the inner planets, and it accounts for over 40% of the volume with Mercury's interior. Now, meanwhile, the surface of Mercury is primarily composed of a silicate rock, and scientists estimate that 70% of Mercury is metal and the remaining 30% is rock. Very interesting. Let's move on to Venus. So Venus is a very interesting planet in respect to how similar it is to Earth in a lot of ways. So Venus is the closest planet to Earth and the most similar to our world in terms of size and mass. Since Earth and Venus are located so close to each other, they are similar. They have similar compositions. Venus is believed to have an iron core surrounded by a mantle and crust composed of rock and metal. Unlike Earth, however, the surface of Venus is dominated by volcanic rock. Furthermore, the atmosphere of Venus is significantly different from our world. The Venetian atmosphere is 96% carbon dioxide, which causes the planet to experience a runaway greenhouse effect that creates the highest surface temperatures in the solar system. That's interesting. The highest surface temperatures in our solar system is Venus. All right, let's talk a little bit about us. So then there's Earth. I think we all know where that is. So like Mercury and Venus, Earth has a core composed mostly of iron, along with small amounts of nickel and other metals. The surface of our world is dominated by silicate rock. Thus, the Earth has many similarities to the other rocky planets in terms of composition, yet one very unique aspect of our world is its atmosphere. Unlike every other planet in the solar system, the Earth's atmosphere contains high amounts of oxygen, and oxygen makes up 21% of the atmosphere, while nitrogen makes up 78%. The remaining 1% is composed of various other elements and compounds, such as argon, carbon dioxide, and methane. Now, the most talked about planet in recent years, Mars, and that's the one eventually we're going to be going over to see. So Mars is the outmost of the rocky planets and is perhaps the most studied planet in the solar system after Earth. Like the other three rocky planets, Mars has an iron core surrounded by a surface of silicate rock, yet there are some unique features to Mars, such as frozen carbon dioxide and monoxide at its poles. The atmosphere of Mars is around 90% carbon dioxide, yet the atmosphere itself is too thin to induce any kind of a significant greenhouse effect, and so the surface remains bitterly cold. And of course, there's the caps and the poles, and we've landed on it, and we've seen all kinds of things with Mars. And when it's visible, and a lot of us imagers who like to take pictures of it, it's one of the most interesting planets if we don't have any dust storms on it, and the and the seeing is good, and the Mars is in a perfect position. It's a really amazing planet to image for sure. So between Mars and the next planet is the asteroid belt. I'm not going to talk a lot about that, but I think we've got some things out there that are of interest to us now. So maybe on another show we'll get into that. So let's talk about Jupiter. This is the one of the planets that when we do our star parties, it is certainly one of the most looked at ones through telescopes. Now, Jupiter is the largest, most massive planet in the solar system, and despite its large size, its composition is rather simple. Jupiter is primarily composed of just two elements, hydrogen and helium, along with trace amounts of chemicals such as water, sulfur, methane, and ammonia. Around 90% of Jupiter is hydrogen, while the remaining 10% is almost entirely helium. However, although the chemicals only exist in minuscule amounts, they do play a significant role. For example, sulfur and organic compounds are believed to be the reason behind various shades of red in Jupiter's atmosphere. Although hydrogen makes up most of Jupiter's composition, not all of it comes in the same form. Deep down, the upper cloud layers of Jupiter, pressure and temperatures become so high that hydrogen becomes a metallic liquid. And this layer of liquid metallic hydrogen is able to conduct electricity, which in turn generates the magnetic field of Jupiter, which is the largest of all the planets. And I'll get in a little bit later about some other stuff on Jupiter. Let's move on to the showstopper at all the star parties. This is the one that gets the most wows from everybody who looks to a telescope the first time, and of course, it's Saturn. So Saturn is very similar to Jupiter in terms of composition. Like Jupiter, Saturn is primarily composed of hydrogen and helium, along with trace amounts of chemicals. Despite its nearly identical composition, however, Saturn looks significantly different than Jupiter, almost as if it's a watered-down version of Jupiter. This is likely due to the fact that Saturn is located much further from the sun. It also is likely due to the presence of a layer of ammonia ice crystals in the planet's atmosphere. And of course, the rings of Saturn are what make it so special. I don't think Saturn would be near as special if we never had the rings that we can see from our perspective here. Not to say that other planets don't have rings, they do, but Saturn is just one of those ones that were first discovered. We thought it was the only one many years ago that had rings, and it's fantastic when they're actually turned at the right angle. So that is our friend Saturn. Next, we have Uranus. Now I'm gonna kind of group Uranus and Neptune into one because they are quite similar with each other. In fact, they're almost the same size. Like Jupiter and Saturn, Uranus and Neptune are both primarily composed of hydrogen and helium. However, the two outmost planets, besides Pluto, let's not forget Pluto. I think we here at the Sunday night astronomy show are advocates of Pluto.
Oh, absolutely. Yes, we have to be. Yeah. Or Pluto.
So hydrogen and helium are not as abundant on Uranus and Neptune, and there is a higher presence of other chemicals. Interestingly, the densities of Uranus and Neptune are primarily determined by the existence of various ices in their atmosphere. And so rather than being classified as gas giants, they are actually classified as ice giants. And Uranus and Neptune both contain higher amounts of methane, ammonia, and water. In fact, the presence of methane, is believed to be the cause of both of Uranus and Neptune's being blue or having that bluish glow to them. So, so that's just a little bit of run of the planets and what they're actually made from. And that's Neptune. So now let's just talk a little bit about the physical size of the planets. So in diameter of the planets, Mercury is 4,800, almost 4,900 kilometers. Venus comes up at 12,000 kilometers. That's quite a difference in size. And Earth is 12,756. So, so Earth and Venus again are very comparable in many ways, also including the size. Mars, however, is a mere 6,700 kilometers. Then we hop over to Jupiter, and of course, it's the largest one in our solar system, and it's at 139, might as well say 140,000 kilometers diameter. Saturn comes in second at 116,000 kilometers. And then, of course, Uranus is at 50,000. Neptune, for the sake of 700, is another 50,000. And our little buddy Pluto way out there is at 2,400 kilometers. So Neptune is about half the size of Mercury, or Pluto, sorry, is about half the size of Mercury. Some of the other things that are out there, we have in comparison are some of the moons that you'll see in our that are associated with the various planets. And what this is actually a scale that goes from the largest down to the smallest. And so it begins with Earth, then Venus, then Mars, then Ganymede, which of course is a moon that belongs to Jupiter, Titan, Mercury, Callisto, Io, our moon, Europa, Triton, Pluto, and then it goes on and on and on into other smaller moons that are up there. So it's really interesting to see, how much planetary bodies that we actually do have up there. Now, are some of the moons of the solar system to scale. So if you look in each of the corners, like the top corner here is Earth, this corner over here is Saturn, down on the bottom is Jupiter, and over here is Uranus, and Mars is in the center. And so you can see that these are the scales of some of the moons that are associated with those planets. Now, Mercury and Venus don't have moons. They're the only two out there that don't have moons, other than Pluto when it was included in our solar system. So there's a lot of moons, and these are actually to scale. So when you look at the size of those versus the size of some of the other ones, some of them are mere small rocks versus other ones that are actually quite large planets, really. So that's just the planet sizes. So we kind of covered that. There is something else I want to go over. Let me see if I can find it here. If I click out of this, I probably clicked out of everything, did I? No. Okay, just bear with me 1 second until I find the other thing I want to talk about. And I think, I think it's this one here. Yeah, here it is. So the planets' moons. So we'll just cover just a little bit of that. So Mercury and Venus up first are Mercury and Venus. Neither of them, whoops, you're not even seeing this. That's over on the other page, isn't it? Oh no, can you see that?
Yeah, we can see it.
Okay, it says the planets' moons?
Yeah.
Okay, all right, great, thanks, sorry. So Mercury and Venus neither of them has a moon, because Mercury is so close to the sun and its gravity, it wouldn't be able to hold on its own, its gravity wouldn't be able to hold on to a moon. Any moon would most likely crash into Mercury or maybe go into orbit around the sun and eventually get pulled into it. Why Venus doesn't have a moon is a mystery for scientists to solve. Up next is the Earth, and of course we have one moon. Mars has two moons. The names are Phobos and Deimos. Next are the giant outer planets, and they have lots of moons. Jupiter, for instance, has known 95 moons. And most people think, when they look at Jupiter, they say, oh yeah, that's the one with 4 moons. Well, that's the ones that you can see through binoculars. And those are the ones that Galileo Galilei that had discovered, and of course that's the name of the Galilean moons. And so those moons are big enough so you can see them with a pair of binoculars. The most well-known of Jupiter's moons are pronounced Io, Europa, and Callisto. And Jupiter also has the largest moon in our solar system, which is Ganymede. Now, as of June the 8th, 2023, Saturn has 146 moons, and that's not counting Saturn's beautiful rings. Saturn's moons have great names like Mimas, Enceladus, and Tethys. One of these moons, named Titan, even has its own atmosphere, which is pretty darn cool for a moon. Uranus has 28 known moons that we know of, and some of them are half made of ice. And lastly, Neptune has 16 known moons, and one of Neptune's moons, Triton, is as big as the dwarf planet Pluto. So that is that part. And I think, let me just see if there's anything else on this. Back into my file one more time. Oops, where'd it go? Here it is. I think there was one more slide I wanted to show, and it might have even been this one. Or was it this one? I think it might have been this one. Yeah, there we go. So, so I wanted to show this again because part of what I didn't mention on this, with all the moons that are there, and what this image actually represents, is that these are based on moon radius, and some moons are sub-pixel in size, but appear to occupy a single pixel. Moons considerably smaller than a pixel have been omitted. Units are in kilometers. So these are only a handful of the moons that are out there, but because some of those moons in this image would only represent a pixel size or even smaller, they just don't put them there. So, but these ones that are here are a pixel size and larger up. So there's a lot of really cool moons out there. So anyway, so those are the things and the facts that I wanted to pass along about the planets that I was learned about this week. And there's a lot to know about what's going on up there. So when we say, oh, let's have a look at Saturn, well, there's a lot to talk about with Saturn. Or let's have a look at Jupiter or Uranus. There's lots going on in each and every one of those planets. So it's an easy thing to find on the internet, the information about this. And it's something, if you've got 10, 15 minutes and you want to just burn through some of these things, because most of these planets, one time or another throughout the year, we can see. So it's really nice to know some of the things about them rather than looking at it with a smartphone and that kind of thing. So
what you're trying to say is that if you're going out for the evening, you make sure you plan it.
Yeah, plan it. Go up there and plan it.
Thanks, Paul. No, that's great. I mean, it's always nice to have a few facts, sit around a campfire and talk about Uranus, whatever.
Yeah. Indeed.
Indeed. Okay. So yeah, that's some info on that part. Mine's going to be a little bit different, but I wanted to share a little bit of information about where they are, why they are where they are, and basically the show that we're supposed to see tomorrow and what it's going to be all about. So give me a second here. I'll get my screen up and going. I think it should be this one. Are we up there? Yep.
You are.
Okay, so the planets in our viewing chances this summer. Now, I get into a couple of the larger ones. Well, Jupiter and Saturn are the two that are the most favorite anyway, I guess. And Mars can be too, but it all depends on its placement. Now, first of all, I have no formal training in astronomy. I'm not an astrophysicist. I don't have any background in astronomy except for what I've tried to learn on my own. So if I'm going through some of these terms and they don't make sense, it might be because they don't make sense to me either. So I'm going to try to bring up as much information as I can to try to help you understand what I've been looking at in charts and things and how I see things the way they are in my mind. This is all in my mind, I guess. So anyway, okay. So this is our parade of planets tomorrow morning at roughly 5:10 a.m. This might be a little bit late, but you can see that Jupiter and Mercury are just breaking the horizon or just above the horizon, maybe just a couple of degrees or so. At this point, when the sun is not quite up yet, sun's up around 5:39 tomorrow. So this is supposed to be the arrangement. This is what they're talking about through the media. Actually, I was on with a gentleman from CTV National News this afternoon, and we had a little short talk about what's going to be happening tomorrow morning. So I'll probably have a 10-second segment or so, maybe tonight on the news. Anyway, it was nice that they called and chatted about it. But this is the alignment that we were talking about. So the planetary alignment that we're seeing tomorrow morning, and it's not just tomorrow morning. I have to understand that the big hype is over tomorrow, but I'll show you as I get into this where it leads into other things. So let's pretend that it is 5 o'clock tomorrow morning. And what are you going to see? Well, you won't see this guy because that's Neptune, and you need a telescope to see that one. And Uranus down here, you're going to need a telescope to see that one too. Now, unless you have really good star charts or you're very good at finding objects in the sky, somebody like Kurt, I assume, would be able to find them. You're not going to know exactly where they are. And even through a telescope, for me, when I'm looking at Uranus or Neptune, they just appear as a soft ball, even through my largest telescope. they appear, there's no detail at all. I might see, it may be a slightly green ball for Uranus and a slightly blue ball for Neptune, but it's like a soft ball. It's not a star. You can tell it's not a star because it's not a pinpoint. But that's about all I see when I see those two objects through the telescope, that I can say, okay, I've seen those objects. So they're not really that impressive even through a large telescope. Hubble may be different, but we're not talking about Hubble here. We're talking about things that we have here, common telescopes. So Uranus, Neptune, forget about those two. Saturn, it's the distance away. It's going to be dim in the morning sky at that time of the morning. And we're going to talk about why it's going to be dim as well in a few other slides. We do have Mars there too. I've got the moon just inflated a little bit so we can see it here. The moon will be up as a very small, thin crescent moon. And down here again in the corner is Jupiter and Mercury. So there's your planet parade. And out of that planet parade, you're going to see Mars and Saturn and the moon. Realistically, that's what you'll see. Uh, I'm not one to encourage people not to go out. I mean, I'm always encouraging people to go out and take a look around. So I'll never say don't go take a look at it. If you've got clear sky and I was close to a spot where I could see this, I would certainly be out tomorrow to take a look. But there are other planet parades coming up, not that far away too. So we'll talk about that a bit. So getting into a little bit more, go this way. These images are coming from a website called heavens-above.com. I go to this site a lot because I like the way it puts things together. And it took me a long time to look at this picture and see what it's all about. Like it took a long time before the light bulb come on and said, oh, now I know what they mean. So this diagram here is the inner planets. And because it's only this large, we couldn't squeeze them all into that little square. So we magnified it a bit. So we got the sun here, we got Mercury, we have Venus, and here's Earth, and here's Mars. Now, if you could take that square and drop it back in here again, you'll see that Earth is over here, and all the planets are on the other side of the sun right now. That's what we're talking about. So we're looking back into the ecliptic, that line that runs up from the horizon across the sky, and that's the plane of the planets, and we're seeing all the planets in that plane all lined up. So that's why we're seeing this as an alignment. So here we are again, Earth here and everything else over that side. Now, put that in a little bit more perspective. This site again provides a lot of detail, a lot of information. It's one of the better sites, I think, for myself. So when I go into this, I look at this page called the Planet Summary, and I'm going to talk about a few things down here. One of them is the brightness. This is the brightness of the objects and magnitude. So the lower the number, the brighter the object. And there's a reason for that. I won't get into that explanation now, but when you're looking at something like minus 3.8, it's actually exponential as well. So Venus is much brighter than Mercury, I'll just say at this point, and Mars is dimmer than Mercury. Jupiter is roughly about the same as Mercury. Saturn is much dimmer. Work our way over, of course, Pluto is very dim. But now we're going to look at the rise and set times here. So these are the times that these objects right now on the 3rd will be rising. 5:04 in the morning, 5:42, 3:35, 5:09. So we can see if we go across that line, 5:04, that's getting pretty close to sunrise. So Mercury is going to be very dim. 5:42 for Venus, not visible because that's after the sun has risen. Mars, 3:35. Okay, it's up. It's up before civil twilight, so we can see it. Jupiter, 5:09, 5:04. No, you're not going to catch it either. And it's down too close to the sun. That's why. Saturn, no, it's up at 2:22, so you should be able to pick up Saturn. So we got Saturn and Mars that are really the two that we're going to get a chance to see. And we can look at the set times here too. We're not going to bother with that right now. But there are other things that we can talk about called inferior conjunction, superior conjunction, eastern elongation, western elongation. We're going to touch on those top 4 topics right quickly. So let's spin ahead to the next slide. What am I talking about? Well, I mean, if we have Earth here, the 2 planets that are on the inner, that are closer to the sun than us, are called the inferior planets. And all the planets that are farther away from the sun than us, we call those the superior planets. So the inferior planets can be at inferior conjunction, like between us and the sun or on the opposite side of the sun. But the superior planets can't be between us and the sun, so they can never go through inferior conjunction. But they can go through something called opposition, when we will be lined up with them, the sun, us, and a planet across the sky. Venus and Mercury cannot be at opposition with us. So that's the two differences between what we're going to be talking about here in a second. Okay, let's go ahead to one more. So superior conjunction. So this is the inferior planets we're talking about. So we're talking about Mercury and Venus here. So if we're at inferior conjunction, that means that Mercury or Venus is between us and the sun. So we can't see it in the sky because it's between us and the sun. Actually, it would be an eclipse. That would be the same thing as a solar eclipse that we saw recently, whether that was the moon blocking out the sun. But those two planets are at an angle too, so we don't always get a chance to see Mercury passing in front of the sun. But they can also be at superior conjunction on the other side of the sun. So there again, we would never get to see those objects because they're opposite the sun from us. There is something called a greatest eastern elongation and a greatest western elongation. Now, because the planets orbit at an angle, I'll say, there's a point when they are the farthest east they can be in our western sky, so at sunset, and there's a point when they're the farthest west they can be in our sky in the morning sky. So that's the 2 points called greatest eastern and greatest western elongation, the farthest away they can be from the sun for us to view them. All right, so from there, let's carry on to something else. Here's another picture of the greatest eastern and western elongation, a better explanation of it. So inferior conjunction is when the object, the inferior planet, is between us and the sun. We covered that. Superior conjunction is when it's on the opposite side of the sun from us. We can't see it then either. Here's the greatest eastern elongation, the greatest western elongation. And you're going to see the eastern elongation in the evening sky. So as the sun sets in the west, Mercury or Venus is going to be the farthest east that it can be in our sky. That would have to happen in the evening sky. In the morning sky, greatest western elongation would mean that's the farthest west it can be in our morning sky. Getting everybody confused? Hope not. Okay, so here's a typical example. So Mercury is going to be at its greatest eastern elongation on July the 22nd of 2024. So there's the orbit of Mercury. And we can see that it reaches this point out here. That's as far as Mercury can go. It takes 88 days to orbit the sun. So it goes through these eastern and western elongations, inferior conjunctions quite often. More often than any other planet, of course. So it's going to be at its farthest east it can be in our sky. Now, is that going to be the time when it's the best viewing? Better viewing here for sure, because the sun will have set and Mercury will still be up in our sky. So you have a better opportunity to see Mercury if you haven't seen it when it's at its either greatest eastern or greatest western elongation. Okay, now we're going to talk about conjunctions and oppositions. So now we're talking about that was the inferior planets, the planets between us and the sun, Mercury and Venus. Now we're going to talk about the planets that are farther away from the sun than us. And those are called the superior planets. So they can enter into something called an eastern or a western quadrature, and that's almost the same thing as elongation. I won't talk too much about that. I want to really talk about this part. So Jupiter was just recently in superior conjunction behind the sun from our point of view, so it wasn't visible. But we also have a time when the superior planets are exactly opposite us and the sun. So these opposition points is when that planet is at its closest approach to us. It also means that when the sun sets, that planet is rising, and when the sun rises, that planet is setting. And at midnight, that planet is at its highest point in our sky. So these are the ones that we really do enjoy the most. We're talking about Jupiter or Saturn. We're talking about when it gets closest to opposition is when it's the brightest in our sky and when it's the largest in our sky that it can be. So those things come up every year because we only take 365 days to go around the sun. I mean, Jupiter takes 12 years and Saturn takes 30 years. So we catch up to these planets every year at different times. So we're back to our chart again. So we talked about inferior conjunction when a planet is between us and the sun, and the only two that can be is Mercury and Venus, sorry. They're the only two that can go between us and the sun. Superior conjunction, all of the other planets, you can see them all lined up here, can all be between us. I'm sorry, all the planets can be on the other side of the sun opposite us, for sure. Now, opposition, though, can only happen to planets that are farther away from the sun than us. And these are the dates that I've got circled here that these events all happen. So moving a little bit farther ahead, we're going to talk a little bit more now why we can't see Jupiter and Mercury tomorrow morning. If you use binoculars, possibly if they've come up above the horizon in time, but I'd be very cautious using binoculars when the sun is about to rise as well. So you got to be very careful with that. So we can talk about things called what we talk about day and night, of course, sunrise and sunset, but there are other terms that are related to astronomy as well. One is called civil twilight. Another is called nautical twilight. And then a third one is called astronomical twilight. And then you have the actual nighttime. And Paul talked about this. It was last week, Paul, or the week before. You had discussed this a little bit.
Yeah,
I'm
it
not
was
sure.
last week. Yeah.
Last week, yeah. So a little bit about those terms, just a small amount here. So civil twilight is when the sun is about 6 degrees below the horizon, either at sunset or sunrise. Now, at civil twilight, only the very brightest stars are visible, and that's even tough. Now, with nautical twilight, the sun is about 12 degrees below the horizon, and the stars increasingly get to appear in that point. Now, astronomical twilight, the sun is about 18 degrees below the horizon, and even the faintest stars can be seen then. Now, that's the earliest phase that you can actually see the Milky Way before you get into what's called really nighttime. So pay attention to this civil twilight one. That's one I want to talk about the most here. So here's another site, timeanddate.com, and they have an excellent site as well for references for eclipses, sunrise, sunsets. Whenever I want to see what the phase of the moon is right now, or when it's going to rise or set, if I want to be able to show it to people and they're out at outreach, I'll go there and take a look at what they have posted. So let's take a quick look at this. So here's sunrise and sunset for tomorrow, June 3rd. Sunrise is at 5:38, sets at 9:06. So we're looking at the rise right now. And if we take a look over here, we'll see the nautical twilight, civil twilight, and astronomical twilight. So civil twilight is when the sky is the brightest just before the sun comes up. So that starts at 5:01. So if the sun is rising at 5:38, let's remember that 5:01 time or 5 o'clock time, because we're going to go back now to our chart again and look at Jupiter. And if we go down to Jupiter, we'll see that it rises at 5:09. 5:01 was civil twilight. 5:09 is when it rises. It's rising after civil twilight. So it's the sky is very bright at that point. And that's because Jupiter is at superior conjunction on May 18th. So it was on the other side of the sun from us on May 18th. That's not that long ago. And Jupiter moves fairly slow in the sky compared to us, of course, because it takes 12 years to go around the sun. So it's not very far away from the sun right now. So that's why Jupiter is a difficult one to see. Mercury, if we want to talk about it as well, Mercury was at superior, or goes to superior conjunction on the 14th of June. So that's only 2 weeks from now. So it's going to be fairly close to, it's going the other way. It's on its way to be behind the sun. So it's also very close to the sun from our point of view. And it's also caught in civil twilight because it doesn't rise, it rises at 5:04. So that's why Jupiter and Venus are, or Jupiter and Mercury are tough to see in tomorrow morning sky. Saturn, on the other hand, if you look at Saturn, Saturn rises at 2:22. Well, sunrise is not till 5:39, so you've got 3 hours before sunrise that Saturn will be up. So Saturn will be visible in the nautical twilight stage or astronomical twilight stage, which should be easy to pick out. Mars rises at 3:35, which is still 2 hours before sunrise. So it's still visible. It'll be dim. And Mars is never very big anyway, unless we're at opposition. And we don't reach opposition with Mars until January 15th of 2025. So that's a little ways away. Okay, so back to our chart. Here's our view again tomorrow morning, and that's why Saturn will be visible tomorrow. Neptune will not be, or Uranus, because you need telescopes for those. Mars, slightly dimmer than Saturn, or maybe about the same brightness as Saturn. Jupiter and Mercury, forget about it. You're not going to get a chance to see them. So that's where I go for information to let me know about where things are going to be in the night sky. And when I'm out to determine whether or not I can offer it, I'll use a program called Stellarium, which is a great one as well. But sometimes I'll take a quick look at this, say, hey, is Jupiter available for me to offer through outreach tonight? And I can just go in here and punch in another day and time, and it'll repopulate with the proper numbers again, the rise and set times and the brightness and all that kind of thing. So Saturn in opposition, that's the time when you really want to enjoy Saturn. Now, Saturn in opposition was back in, Saturn opposition is going to be in September of this year, September the 8th, right around Labor Day weekend, which is about the time when we do our Fundy Star Party event. So Saturn will be at its best when we're down at Fundy National Park offering our Star Party event. So as we get closer and closer to opposition, Saturn gets brighter and brighter and higher in the sky, so it's better visible. We want to have it as high as we possibly can because we want it to get up out of that real thick atmosphere that we're looking at. So that's Saturn in opposition. And move ahead one more time here. So we are at Saturn. So it's the Sun, Earth, and Saturn all lined up when it's at opposition. So as the sun sets, that planet is rising. As that planet sets, the sun is rising. And it's at its highest point due south at midnight. Jupiter at opposition, again, we have Earth, the Sun, Earth, and Jupiter all lined up, and we catch up to Jupiter every year because Jupiter only takes 12 years to go around the Sun, and we're only taking a year, so we're catching up to it every year. And its opposition is going to be at December the 7th. So we will be waiting. We'll have Saturn up to opposition. We'll enjoy it after opposition for quite a while, and all of a sudden Jupiter will be the next target, our nice gas giant to carry us through Christmas. So another nice show there. And here's what Jupiter would look like at opposition compared to Jupiter's solar conjunction. In other words, when Jupiter's behind the sun, that's how big it would appear. And here's how big it would appear at opposition, scaled up, of course. So much closer to us at opposition than it is at solar conjunction. And there's our final view again. So that's why we're not going to see the planet parade tomorrow, as well as everybody's talking about. But fear not, because even later on in June, actually in August 29th, we have another planet parade coming up in the early morning sky, 1 a.m. Well, I'll say late evening of the 28th, early morning of the 29th. And as we move through the month, really, Jupiter will continue to climb higher and higher in the sky. So that means it's going to be up earlier in the sky. So we will have Saturn, Mars, and Jupiter in good location closer to the end of the month, closer to the end of June. That's when they're going to appear. So that's about all I got to say about that. Hopefully some of that made sense.
Well, there you go. So I hope nobody's in opposition to that and they don't feel superior to us.
Or inferior.
Because we'll have to have an injunction.
Well,
Oops, I fell again. I fell last week too.
you did. It's a neat picture. If you can go to Heavens Above website and click on the solar system chart, that chart that I showed at the very beginning with the planets, inner planets and the outer planets, and it shows you where Earth is in relation to all the other planets. All of a sudden, the light bulb will come on and say, "That's why that's where it is." That's what I did a few years ago, and ever since then, it's been like, wow, okay, that makes sense now.
Makes sense.
It took a long time for that light bulb to click on, but when it did, it was like, wow, okay. And again, I don't have any professional training. It's just a matter of trying to get that in your head, right? Especially when you're trying to offer it to folks out there.
Yeah, I'm
So
just trying to get
that's our talk about the planets. Let's hope that we have a good
Before
show
we-
at the end of June. But yeah,
See, before we go any further, I just want to give a shout out to Annie, our friend. Annie's a friend of ours from up in the Moncton area, Moncton Dieppe area. And I have yet to give Chris and Mike theirs yet because I haven't run into them, but Annie sent us something very special. And I just want to kind of show it because I really feel so blessed to have it. She actually had our photos of our eclipse experience put on these nice mugs, which I'm going to be starting to use for my coffee every week here in the show. And then it says, I was in the path in Florenceville, Bristol. New Brunswick, and then of course on the very small print it shows the date that we were there. And Annie sent this to us because she really enjoys the show. She enjoys what it is that we've been doing for the past few years, and she's inspired by what we have to offer. And so I want to say thank you so much for doing this, because that's these kind of things that inspire us to continue on this show and do what we do. So Annie, thank you so much. I really appreciate that. And this is my new favorite mug.
Thank you. It means a lot to us. Thank you very much. Okay, so we're going to go on to a Rosanna's fun fact now.
Okay. All right, let's see if I can't make this happen, number one. All right, and I'll share that, and that's this week's
Rosanna's fun fact.
Hey, welcome back, Rosanna, for another absolutely wonderful fun fact. And this week, Rosanna writes, hi, Paul. Once again, we have something exciting coming our way in the skies above. Actually, there is always something to catch your imagination and cause intrigue. Unlike the solar eclipse of April the 8th, which was timed to an exact moment, this event will just happen sometime this year. And I hope we all don't get a crick in our necks while waiting. Now, let me just see if I can get my picture slide set up, because there we go. Let me get that one off the screen. Yeah, I know this is day 238, but I swear, just keep looking up. So to get ready to see something new in the night sky, a nova, a giant stellar explosion, let me just get that up, there we go, is expected in the star system T Carinae Borealis, or TCRB, also known as the Blaze Star, which is something that Kurt had talked about a while back. Sometime between now and the end of the year, likely creating what will look like a new star about as bright as the North Star or Polaris. So it's going to go from this to this. Now, the star, actually a binary star system comprising a white dwarf and a red giant, is for the most part not visible from Earth without the aid of a telescope. Lying 3,000 light years away from Earth, the white dwarf's gravity slowly pulls away material from the red giant. As the red giant expands, it engulfs the white dwarf in hydrogen gas, which eventually gets hot enough to undergo a nuclear fusion reaction and briefly gets more than 500 times brighter, eventually producing a once-in-a-lifetime, or twice, if you are incredibly lucky, event. So this happens around every 80 years or so. We know this because of the observations in 1866 and 1946, when the star system T Carinae Borealis brightened several thousand-fold and became visible to the naked eye. The star appeared almost as brightly in the sky as our North Star, Polaris. But just to clarify, a nova isn't super. I'm sure it's still a super thing to observe, but a nova is a much smaller stellar explosion than a supernova. And here's an image of a thermonuclear explosion on the surface of a white dwarf star known as nova. And this is an image from NASA. Now, nova or novae are also much less rare than the last nova to happen in the Milky Way, which was in 2022. And I couldn't find an image of it, but I did find this one from 2013, Nova Centauri 2013, as seen with the naked eye near La Silla Observatory. Now, it's pointed out right here. So that circle right there would have been that Nova Centauri. We haven't seen a supernova in our galaxy since, get this, 1604.
Wow.
Now, the Blaze Star nova may have been observed in December 1787. Reverend Francis Wollaston Observaday observed and documented a star in T Carinae Borealis's position, likely to be the Blaze Star going nova. And here is the star mapping of the 1787 sighting. So there's Corona Borealis, which is what Kurt was talking about last week, the week
2
before.
weeks ago, yeah. 2 weeks ago.
Yeah, and there is there's the Blaze Star right there. We also have a far older description of the star going all the way back to the 13th century Bavaria. The 1217 event has an eyewitness report written by Abbot Burchard of Upsburg as a fast rising stellar point source, or stella, in the T Coronae Borealis that shone with great light, lasted for many days, and was described as being a wonderful sign. Bradley Schaefer, professor emeritus at Louisiana State University Department of Physics and Astronomy, wrote in a 2023 paper published in the Journal for the History of Astronomy. And here's one way to find that blaze star. So of course, there's the Big Dipper. So when we're taught, one of the first things we're taught is look to the handle of the Big Dipper, arc to Arcturus, and then once you're into Arcturus, you're going to see the crown of Corona Borealis, and basically you're just going to look right down, and it's going to be right in this area here. If you go too far, you're going to see that really, really bright star Vega. So that's a little way to find it. And another way, borrowed from Kurt's newspaper article, was this one here. So it shows the Corona Borealis, and as he says, so there she blows, and as soon she will. We just can't pinpoint when. I'm excited to see the blaze star go boom, whether live through a telescope or just vicariously through the internet, even if it's not super. Remember, it's just nova, not supernova. And that's this week's, whoops. Try that again.
Rosanna's Fun Fact.
Hey.
There you go. Thank you so much, Rosanna. That was really, really cool, and it ties in as timelessly as she always is with Kurt's talk of late.
I was down to St. Therese Beach last night. I was looking at Corona Borealis, and I was seeing if anything had flared up yet, but not yet. But so keep an eye out. That's going to happen. It's going to be fantastic when it does, for sure.
Yeah. So just find a spot that you like, lay down, get some binoculars, and have a time.
Easy to do. Easy to do. Okay, we're going to get.
Remember to play it.
Remember to plan it. Thank you, Rosanna. All right, let's get to just a few photos. Then we're gonna close out our show. Hang on. Go this way. Where's it gonna come up on? I don't know where it's gonna come up. Oh, come up here. Right over here. Just need a few notes here to read. This one, I think. Only got like 25 windows open. Great. Okay, let me share my screen. I guess that's what you got to do next. Let's go to. Okay, so this comes in from David Hoskin. David says, "Hi Chris, I captured these filtered white light and hydrogen alpha images of returning sunspot 3664, now renumbered AR 3697. Now it is still active, although not as large as it was the first time around. That's true. I am paying attention to this big prominence though here. This is really interesting, this long filament. Apparently it's magnetically attached quite well, but if that happens to let go as well, who knows, right? But there's that sunspot grouping now that was 3664, that one that did all the aurora, or resulted in the aurora, I guess, of May 10th. So will that continue? Now it's moving around to our location. It's going to start facing Earth very soon, next couple of days or so, and it is active again. It actually right now we're at the highest level of X flares apparently since the last solar cycle already. So we don't know. We're not at the maximum yet, but we're getting very close. So we'll keep close eye on this big boy over the next number of days and see if there's any activity coming back from that. So thank you, David, for that. Appreciate that. Let's move on from there to our next one here from Jennifer DLG. So Jennifer says, "Hi, Chris." She says, "When the sky gods have allowed, I have had my C-Star S50 churning away, getting data on some of the more visible galaxies. Now enclosed is data on some on a couple of the results which were processed in Serial, RA Expert, and Photoshop Elements. It has all been a fun learning process, she says, and I feel I am making a little progress. You certainly are. Nice job.
Hmm.
That turned out nice. NGC 4631, that one, the Whale Galaxy, was produced from 44 minutes of integrated data captured over 2 nights. And our next one up was the Cigar Galaxy M82, which was produced from 53 minutes of integrated data captured over 4 evenings. Great job, Jennifer.
There you go.
Nicely done. And she said, when I replied to her, said we're going to put them up on the show, she sent me this one as well. She said, I just finished working on this one, which I processed with the Hubble palette scripts in Serial. So she said, I really love it. It is awful nice.
Yes, the eagle.
Nice eagle, yeah. Pillars of creation.
That was a creation there. Yes, sir.
Nicely done, Jennifer. Thanks
Yep.
for that. Sharing. Looks like you're having fun with that C-Star. I got these ones from Brad Perry. Brad says, just sharing a few photos from the past couple of weeks. He said 2 are of the full moon as it was setting on the morning of May 24th, around 5:30 a.m. Taken in Fredericton. For that, nice job.
Yeah, yeah.
There's a guy who puts himself in the right spot.
Yeah. He's been doing it for a bit. He's very scientific about it, so it's
Sure
awesome.
is. Great job. Thanks, Brad. Now his third photo is of the Milky Way. Look at that. Yeah. Looking
nice.
across Grand Lake on the night of May 29th around midnight. So there's our Milky Way already.
Beautiful.
Yeah. Look at the prancing pony there. Can anybody see the prancing pony?
I sure
No.
can. Once you see it, you can't unsee it.
Can't unsee it. So turn your head to the side and look there, and there's his head, and there's his legs, his back, and his other back legs. So the prancing pony sits right in there. So again, yeah, like I said, once you see it, you can't unsee it.
Yeah, very nice.
Very nice. Thanks for that, Brad. And way too fast. Wait, here we go. And this
Oh,
one from Rowan from last evening from his backyard, he said.
yeah, my back deck. I just had to look out before I was going to go to bed around 12:30,
Yeah.
and I said, "Oh, I've got to get a picture of that because I could see the Milky Way just naked eye. I could see, a lot of the stars. Looks kind of like clouds. So I said, "Oh my gosh, I got to go out at least take one picture." And so I just grabbed a camera and I was still in my pajamas. And, threw it out there and took a 20-second shot of the sky and lo and behold, right in the center of that is your favorite constellation.
Mine. My favorite. No, it's not in there. Leo's my favorite. Let us see it.
So
Oh,
if you look right in the center of that, you can see the very center bright star is
triangle.
Deneb. And of course, that's Cygnus the Swan right there. And right above it, if you look up, really bright star. And of course, that's Vega, and that's the constellation Lyra. If you look way down, oh, look, and you can see the coat hanger right there.
There's the
No,
four
wait,
stars there. Oh, you're right there. Yeah, there's a
coat
coat
hanger
hanger.
there, yeah.
There's a
And go
coat
down.
hanger. Asterism. Yeah.
There's your coat hanger. Let's go down a little further.
Yep.
And keep going down.
Okay.
And right there, okay, right in amongst the power lines is Delphinus. Right in amongst the power lines.
Oh,
right
they're right there.
there you go. Yeah.
There it is. Yep.
Yeah, when you zoom out, you can see it better because that's
Delphinus,
yeah, because
that's
it's
my
only a
favorite.
single image, so it's not. Yeah, so that's Delphinus right there, and I got another shot. I didn't send it to you, but another one that also included Cassiopeia, because
Okay.
Cassiopeia is right in line with Cygnus, which is right in line with the whole Milky Way thing.
Yeah.
So it was just a treat to go out and just sit there and naked eye and look at that, and just marvel in how many stars were there and oh, and by the way, did you see the meteor going through the sky?
Yeah. That's not a star.
I had a Tim Doucette moment and had a little bit of
Hey, you
luck.
did. Good for you. Oh, nice shot, Paul. Nice.
It was, yeah. It was nice.
What were you doing taking that shot? What gear were you using?
Okay, so that one I used a 14 millimeter lens on a full frame camera, and I shot it for 20 seconds at f 2.8 and ISO 4000.
Oh, awesome.
Yeah.
Yeah, great
It's
shot.
a really simple shot. Like these shots, anybody can get. Just if you can get to a dark sky like my backyard, and that is my back deck.
Mhm,
It's about a Bortle 3 to 4 probably,
mhm.
somewhere's thereabout sky. And so that just goes to show you, like I'm in a burb, and you can see my neighbor's house across the street. That's lit by a street light, but you can
Mhm.
still get this glorious stuff, with just a camera on a tripod in just a few seconds. So I'm going to do a lot more of that kind of stuff, I think, this year because
Yeah,
it's stuff that you can do wherever you are, and you don't need to drag a bunch of gear and
right.
stay up all night getting 300 subs and
You're staying up all night right now because the sun's still up 10 o'clock, but
that's it. Yeah,
but pretty soon, yeah, that's going to change. But yeah, no,
yeah,
that's awesome, Paul. Great job.
indeed.
All right, let's go from there to this one here from last night, and
So
that's me at the beach. This is where I usually set up St. Tress Beach. Anybody who hasn't been down to see me yet, the coffee cup sitting there in the bottom. Mike Thorne brought me by a coffee last night. He knew I was going to be there, so thank you, Mike, for that. This is Sherry Bartlett. She's a follower of the page and stuff, so she wanted to drop by and take a look at what we could see through the scope. So we did. So
perfect.
it was a really kind of a late decision. So for those who follow my page, I started the page in the beginning just to tell people that I would be at the beach. Well, we're at 21,000 followers now later, and it's
Yeah,
become much more than that. But I still post on my page when I'm going to be there. Sometimes I only give an hour notice, like that might be all I can provide. But I'm always welcome to anybody who wants to come down and see me when I'm set up like that. Like last night, we had I don't know, maybe 8 or 10 people all together for a couple hours, which wasn't a lot. And if you're there, by yourself like that, you get the chance to see the whole sky. We get a lot of, get a lot of things to take a look at, and you're the only one at the eyepiece. So don't forget, like through the week, it's tough for me to get down there because again, it doesn't get dark till you can't start seeing things till really 10 o'clock. And I work 5 days a week, so it's difficult for me to get up the next morning to, after being out like that and tearing that all down and setting it back up again. So I usually set up on the weekends right now at this time of year. But as we get past the longest day of the year here coming up and we get into July and parts of August for sure, I'll be down there more often. So you see me put a post up, anybody's welcome, bring the family down. I'd love to share the night sky with that beautiful spot sitting right on the Bay of Fundy there and listening to the waves crashing. It's a magical spot for sure for me.
well, you get that the smell of the seawater as well, and
Yeah.
it's an experience. Like every time you go down there, it's just I don't know. It's almost like you can feel tension leave your body.
Right, exactly. Yeah, you can, exactly. Now, if it's northeast wind like it was last night, perfect. The fog stayed out a long time.
Yeah.
So southwest wind, take a closer look. You might not want to come down. But we do have had a lot of real nice nights down there. So thanks, Sherry, for sharing that with me and sending that in. Um, we do have our of course our May June calendar that Kurt puts together for us every 6 weeks or so, and here's what's happening for the rest of June. So there's our moon near Mars. I like the way he puts it. He doesn't put the planet parade, he just puts moon near Mars, which is good. So, but there's sometimes there's now next weekend is the Kujipquak Spring Star Fest. So Kujipquak National Park, members of the Royal Astronomical Society of Canada go there next weekend for one of two star parties at that park throughout the summer. So you can find information if you go to rasknb.ca or this sjastronomy.ca, St. John Astronomy Club, click on star parties. You come up with the information for that actual star party event that takes place over 2 days. And there's all the information there about what you have to do to enter the park for that information. So try that out. Kujaquak Starfest. If you haven't been to a Star Party event, there's your first one for the season. And also, of course, Lisa's Lookup. Lisa provides this up for us every month. Lisa's Lookup, Astronomy and More. This is our chart for June. So she lists all the events that are coming up in June, the dates that they're coming up at, your peak time to see those particular events, like the full moon, and what you need for tools, naked eye, binoculars, or a telescope. You can follow Lisa at Ruby Moonbeams on Instagram, X, Twitter, Mastodon, and Facebook, and now Threads, of course. So that's what I got to say about that there. And of course, if you have any images that you want to share with us, please send them into astronomybybay@gmail.com. We love getting them and we love sharing them. So looking forward to seeing some pictures for next week. There.
Yeah.
Now I just need to do a couple of things here. Talk amongst yourself there, Paul. I would say you and Mike talk, but
So we will hopefully Mike was watching tonight. If he's going to watch it on a rerun, that's great. We missed the Bino Bud this week, but Mike will be back next week. and I'll have another albino bud and some great stories of his adventure, I'm sure. So it'll be nice to see and talk with him next week. And like I say, star party season is just starting. So there's 4 star parties this year in the province of New Brunswick. And the first one again is next weekend at Quishabaquack. They'll have another one in the fall. Then we have the Fundy National Park on the long weekend, the Labor Day weekend. And the week before that, I think it might be 2 weeks. I'll have to check to be sure. But we're also at Mount Carlton, and that's the darker skies in New Brunswick, the highest elevation, one of the most peaceful places that you'll ever be. And it's one of our favorite. We like Fundy because it's more of a gathering and just it's a social thing. We do a lot of astronomy, of course, but we do a lot of social stuff there, and it's just a sort of a star party homecoming for us. And but the Mount Carlton one is more of if you really want to see dark skies, and if you've never been to dark skies, you really need to go to a place like Mount Carlton. We're close to Bortle 1 sky up there. It is so dark. The views are amazing. There's 2 huge mountains up there, and at the bottom of those mountains, there's a huge lake. And if you're a Milky Way enthusiast, it's one of the most beautiful places to get a Milky Way shot. It reflects right in the water, and you got those gorgeous mountains in the background. So, and we do a lot of stuff up there too. So anyway, just a short little thing on the upcoming star parties for New Brunswick. So if you are wondering where do I go in the Maritimes this year, think about New Brunswick, because we do have some of the nicest and most fun star parties that are around.
Absolutely. Thanks, Paul. Okay, so that's our show then for this evening. We hope you enjoyed the program tonight. Special thanks, of course, goes out to Rosanna once again for a fabulous fun fact. Sticking with us, Rosanna, we really do appreciate it. And to all of you who share our program out there, thank you all. Remember, too, we do love getting your photos, so send them in to astronomybythebay@gmail.com. That's the address. And we'll be happy to share them on our next broadcast. Now, special thanks, of course, goes out to our friends at Rogers again for sharing the program with your folks out there this evening. So until next week, wishing all of you clear skies, as we like to say, open your eyes to view the skies and keep your scopes
Point it up.
Thanks, everybody. We'll see you all next week.